back to my channel. So today we are going to study specific heat capacity. Okay, to understand this concept we are going to perform an experiment. Okay, so let me take three spheres, of one of iron, one of copper and one of lead. What I am going to do, I am going to put these three spheres in the boiling water. Put them in boiling water. So when I put them in boiling water, all the three spheres would become of the temperature 100 degrees Celsius. Now put them immediately on a wax slab in a tray. Okay, so this is my tray and this is my wax. So what I see, the iron sphere goes deepest, then copper sphere goes to the intermediate depth, and the lead sphere goes the least. Why this happened? Means, see, when it's going inside the wax slab, that means it's melting the wax, right? That means it's basically giving out its heat. So it shows what? The iron has absorbed maximum heat. Copper has absorbed intermediate heat. And the lead has absorbed least heat. So what it is basically showing, for the equal rise of temperature, the capacity of the three substances to absorb the heat was different. Okay, so that property is nothing but specific heat capacity. It's the property which determines the amount of heat energy absorbed by the each sphere. Okay, so how do I define now specific heat capacity? The amount of energy absorbed. The amount of energy absorbed by unit mass of a substance to raise its temperature by 1 degree Celsius. Is specific heat capacity. Now specific heat capacity is different for different substances. Okay, that we understood by this experiment. Now this specific heat capacity is going to be, to perform this experiment, we need, which principle do we use? We use the principle of heat exchange. Acha, before studying principle of heat exchange, what is principle of heat exchange? Whenever you perform this experiment, we are going to consider the principle of heat exchange. Principle of heat exchange is nothing but you take two objects in a heat resistant box. Means what? The outside heat cannot come inside and the inside heat cannot go outside. So I am taking these two objects. One is hot, one is cold. So this is my hot object, this is my cold object. So what the principle of heat exchange says, that the energy lost by the hot object is equals to the energy gained by the cold object. That is the principle of heat exchange. Energy lost by hot object is equals to energy gained by cold object. Okay? Now how do we calculate the energy lost and the energy gained? Okay? It all depends upon the specific heat capacity. So let me consider a substance of mass, two substances. For the hot substance I am considering substance of mass M1. Okay, and its heat capacity is, specific heat capacity is C1, and the change in its temperature is delta T. Okay? And for the cold substance I'm considering, okay, this hot object is at the temperature T1. The cold object is at the of mass M2, specific heat capacity C2, and its temperature is T2. Okay? How do we calculate the energy lost or gained? It is nothing but M into C into difference in the temperature. Okay? So now I am having this heat resistant box. This is my hot object, this is my cold object, this is M1 and this is M2. Okay? The temperature T1 I am considering is at greater than temperature T2. That means what? Hot object is going to give away its heat, right? And cold object is going to absorb. That means temperature T1 is going to decrease. Okay. See, the exchange of heat always happens till they attain a common temperature. So I am considering the common temperature is T. So the energy lost by hot object by this formula becomes what? M1 into C1 into difference in the temperature would be T1 minus T, right? Is equals to what? Energy gained by the cold object would become M2 into C2 into, now the temperature of the cold substance becomes more. So can I take T minus T2? Okay? So that gives the principle of heat exchange. Okay? Fine. So, okay. How can we calculate? The next thing I am going to tell you is, how can I calculate the heat given or heat lost by a solid substance by mixture method? Heat lost by mixture method. Now what is this mixture method? Basically I am going to do what? I am going to use the calorimetry method. Mixture method is nothing but calorimetry. What you do is, you take the hot solid, right? Heat lost by the hot solid, I am saying. You put it in the mixture and imagine there is a resistance box. In that, you put it in a calorimetry, okay, in the water. So this is my hot object. So this is my water and the calorimetry. So the energy lost by the hot solid is equals to what? The energy gained by the water plus the energy gained by the calorimetry. Okay? So how do I calculate this? Calorimetry specific heat capacity is known to us. Water specific heat capacity is known to us. See, when we put the hot solid, we'll start checking the temperature, right? We'll check the temperature arises when three of them at the same temperature. So my common temperature is attained T. So can I say the heat lost hot solid is Q, let me consider it to be Q, is equals to Q1 plus Q2. I am considering Q1 is heat gained by the water plus heat gained by the calorimeter. Okay? So now how do I find out the heat gained by the water? Simple. Heat gained by the water is nothing but, this is my Q1, mass of the water, specific heat capacity of the water, and the difference in their temperatures. And by the calorimetry is what? Again, mass of the calorimetry, the specific heat capacity and the difference in their temperatures. That's how we find the heat lost by the hot solid. Okay, fine. So how did we define the specific heat capacity? The specific heat capacity is the amount of the energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius. So how would the units of a specific heat capacity be written? Units of C. Alright. The amount of heat required, that is J, right? I'm taking, fine. So to raise what? The temperature of a unit mass of a substance. Fine. So that is kg by 1 degree Celsius. So that is Kelvin. So this is the unit of the specific heat capacity. Okay? If you like my video, do give a thumbs up, subscribe to my channel and do not forget to share it with your friends.